Welcome to The Explainer. Today, we're going to dig into a fascinating engineering puzzle where the answer that feels right is, well, it's completely wrong. It's a concept that can even trip up actual rocket scientists.
Okay, so picture this. You've got a pipe carrying some hot fluid, and you have two different kinds of insulation to wrap it with. The question seems simple enough, but the answer is surprisingly tricky. How do you layer them to stop the most heat from escaping? Which one goes on first?
And get this isn't just some random thought experiment. This is an actual question pulled directly from an entrance exam for scientists and engineers at ISRO. That's India's space agency. So yeah, the stakes are pretty high, and the physics here is very, very real.
All right, so here's what we're working with. Our first material is a pretty good insulator, and we'll just say its thermal conductivity is K. The second one, not so great. Its conductivity is 3K, which means it lets 3 times as much heat pass through it. Now, your first gut reaction might be to slap the best insulator right up against the pipe, but let's hold that thought for a second.
You see, the solution here lies in a concept that isn't immediately obvious at all. We need to introduce the unexpected key to this whole puzzle, something called the critical radius. So here's the wild idea that messes with everything you think you know. When you're insulating something with a small diameter, like a pipe or a wire, adding a thin layer of insulation can actually make it lose heat faster. I know it sounds totally impossible, but it is absolutely true.
This whole phenomenon is defined by the critical radius of insulation. It's this specific outer radius where heat transfers at its absolute maximum. So why does this happen? Well, when you add that first thin layer, you're increasing the outer surface area. And it turns out that bigger surface area lets more heat escape into the air than the insulation can block. It's only after you get past this critical radius that the insulation finally starts doing what you want it to do and traps the heat.
So how do we actually figure out what this critical radius is for our two materials? Well, lucky for us, the exam question gives us the formula.
For our first material, the critical radius is its thermal conductivity, K, divided by H. And don't worry about H, it's just the heat transfer coefficient. It's basically a number that tells you how easily heat escapes from the outside surface into the air. And for our second material, the one that's not as good, it's pretty much the same deal. Its critical radius is its conductivity, which is 3K, divided by that same H. So when you compare the two, the math is really simple. Because that second material has a conductivity that's 3 times higher, its critical radius is also 3 times larger. And this right here, this is the piece of information that unlocks the entire puzzle.
Okay, so now that we know the relationship between the two radii, we can finally figure out how to layer these things properly. The logic follows 3 really simple steps. First, we figure out the critical radius for each one, which, we just did. Second, we see which one's bigger. And third, and this is the golden rule, you gotta remember this, for the best insulation, the material with the larger critical radius always goes on the outside.
So let's apply this to our problem. Material 1, with conductivity K, has the smaller critical radius. Material 2, with conductivity 3K, has the larger critical radius. The rule says the one with the larger radius goes on the outside. So material 2 has to be the outer layer. Simple as that. And just like that, by following the physics instead of our gut feeling, we've actually figured it out. We have the final answer.
And hey, if you don't believe me, the official explanation from the exam confirms our logic perfectly. It says, hence, the first material is to be used inside, and second material is to be used for outside, as it has bigger critical radius. See? It all comes down to that one property.
So the correct answer on the exam is option B. You put the better insulator, the one with the lower K value, right up against the hot pipe. Then you wrap that with the worse insulator, the one with the larger critical radius, on the outside.
So if you take away just one thing from all of this, let it be this. When you're layering insulation, the material with the larger critical radius always goes on the outside. That's how you minimize that weird, counterintuitive effect where insulation can actually make things worse.
And that really leaves us with a final thought, doesn't it? If something as basic as adding insulation has this weird backwards rule hiding inside of it, what other obvious principles in science and engineering might have some surprising exceptions? It's a pretty good reminder to always question things and really understand the why behind the rules we follow.